So this is section 3.5, more optimization, more problems, more applications. Okay, perfect. So Rags Limited, a clothing firm, determines that in order to sell X suits, so X units, good, the price per suit per unit will be the price per unit, P, lowercase p, 150 minus 0.5x. Price per unit. Okay, fine. It also determines that the total costs of producing X suits, okay, C of X equals 4,000 plus 0.25x squared. So cost, total cost. Good. Find the total revenue. Perfect. So that's our first question. R of X, total revenue. So the total revenue has nothing to do with the cost. So the total revenue is always price per unit times units. Price per unit times the number of units. Can anyone tell us how to write the total revenue? Anyone, please give it a shot. It's okay if you're wrong. You have no idea how many times I was wrong. R of X. Price per unit. Yes, go ahead.
X times 150 minus.
Exactly. So it's X multiplied by the price per unit, which is 150 minus 0.5x. Very good. I will distribute, of course. Put it in the correct order. Done. This is part A. Sharing. Part B. Find the total profit. Okay. So in part B, they want us to find the total profit. How do I find the total profit? What is the formula for total profit?
P of X.
Yes, P of X equals
X.
Revenue minus
cost.
Yes. So it's always revenue minus cost. Total revenue, negative 0.5x squared plus 150x, minus, careful, when we distribute the negative 1 to both terms, both become negative. Negative 4,000 and negative 0.5, I'm sorry, I meant to say 2.5x squared. Of course, I'm going to combine like terms because these two are like terms. Negative 0.75x squared plus 150x minus 4,000. This is it. This is the total profit function. Any questions? Okay, now let's see. Part C, how many suits must be produced and sold in order to maximize profit? Okay, so I'm asked to find the maximum of a function. And the function is this. So how do I find the maximum profit? What did we study so far? What is my starting point? What should I determine? What will be next?
Is it the derivative?
Exactly, of course. That's why we, it's the profit function, the rate of change of the profit function. Very good. So when I bring this down, 0.75 times 2 is 150. So negative 150x plus 150. So bring down 2, multiply negative 1.5 times x, and the derivative of 150x. So sorry, I should have asked you. So sorry. So this is 150. What do I do next? So I have the derivative or the rate of change of the profit with respect to units, number of units. What do I need to find next?
Critical numbers.
Yes. So I have to find p prime of x equals 0, solve the equation, and p prime of x is undefined. Well, not possible. It's a polynomial. When I set this equal to 0, negative 150x equals negative 150. So I have x equals 150 over 1.5. So what I'd like to do, yes, you can use the calculator, but there is no need. So this is 1500 divided by 15. You multiply top and bottom by 10 to eliminate the decimal number. And then you have 100. So x equals 100 units. Do I know that this will give a profit, a maximum profit? No, I do not. So I have to study the sign of the derivative. So I still have to create that table. I have to, of course, there is no infinity, but I have to put 100, I have to put 0, and I have to study the sign left and right. This is the derivative. Please plug in a number to the left, like 0. That's the easiest. And give me the sign. I only need the sign. I don't need the number. And then plug in, let's say, 1,000 in here and give me the sign. This is how we know whether it's a maximum or a minimum.
Positive.
Yes, indeed. Of course, positive. And when we plug in 1,000, this will be 1500, right? 1,500 minus 150 definitely will be negative. And this looks good. So it's definitely a maximum. No questions. So if they manufacture 100 units, assuming they sell them, right? If they manufacture 100 units and sell them, they will get a maximum profit. How do I determine the maximum profit? What do I need to do to find the maximum profit?
Plug 100 in.
In the function. Excellent. So here's the function. Not in the derivative, of course, I will get 0. It has to be in the function. So because it's just a number thing, which I shouldn't even do it with a calculator, but let's say 0.75 multiplied by 100 squared, negative 0.75 times 100 squared plus 150 times 100 and minus 4,000. And we plugged in the profit function. And I got 3500. So the profit is, now let's make sure that this is in price pursuit. Okay, so it's in dollars. What is the maximum profit? So how many suits? That was part C. We did. We found 100. What is the maximum profit? We did. So part D, the maximum profit, 3,500, max profit. We know that the sequence of signs for the derivative implies a maximum. Good. And let's see the last question here. What price per suit will maximize profit? So we have to go back here and replace X by in part E. How do we get the price per suit? What price per suit will maximize profit? How much was X? How much was X?
100.
Exactly. So little p, I don't like PP, but remember this is the little p. It was 150 minus 0.5 times 100. So 0.5 times 100 will be 50. 150 minus 50 is $100 per unit. Any questions? Very good pick. It was a very interesting problem. Thank you for picking that. Any questions? Any questions on this problem? So here is what is left from this chapter. So it's easier for